Okay, finished talking about 9.2. 9.2 is a little long, so we'll do two separate videos in case you'd want to just go back and not look at all the write-ups, but some of the stuff we're going to be doing for the second half here can be a little bit confusing, so this might be nice just to watch this video. Anyway, describe a type 1 and a type 2 error. All right, so first of all, there's one thing we got to make sure is abundantly clear, because College Board they do this every year, and it's just amazing that I don't think we have a problem with it, but I think nationwide it is an issue. But they want consequences. They want the consequence of what the error is, even though they might not ask you for it. So that's important for you to know. You need to make sure, I mean, when we have open notes, that's one thing, but when you're taking your AP exam, they will ask about type 1, type 2 errors, and you must give the consequence. Also, when you describe the errors, it has to be in context, which is also a problem. This is typically a pretty unsuccessful. We have to miss this one on the test. Usually we have to miss this a couple times before we get these straight. But here we go. This one was the context of the problem for the AJL and Associates with the fraud, if there's not enough or too many numbers that start with the digit 1. So the type 1 error is that we suggest that there is fraud when in fact there isn't. And then the consequences, they do a more thorough investigation. So the error, describing the error, is that fraud in context, is that fraud exists when in fact it doesn't. Okay, and a lot of you are going to want to stop there, but then you have to say, then what's the results of that? And again, good luck with that. You're not going to want to write one of those up for the first time on your test or the AP exam. So anyway, the consequence is that they would do more thorough investigation when it wasn't needed. Now for the auditing firm, that's more billable hours. That's not even a horrible consequence, to be honest with you. Somebody has to pay, somebody's getting paid. So the consequence is kind of point of view if you want to talk about it being good or bad. But that is still the consequence of the error. A type 2 error is that we suggest there is no fraud when in fact there is. This one we reject when we shouldn't have. This one we fail to reject. And instead of the word to, a lot of times we'll write the Roman numeral, fail to reject. That's what's happening. But that's not describing it. Describing it is we suggest there is no fraud when in fact there is. The guilty person gets away with it and probably continues or escalates their fraud, which that would probably, you'd consider that to be the error with the greatest consequences. Now, they didn't ask us for that, but they will. They typically don't ask you which one's worse. If it's kind of wishy-washy, it's typically pretty clear-cut which one's going to be worse. Lots of times it's life versus money. So they talk about saving money versus the loss of life. You're going to say the loss of life outweighs the loss of money. That's typically what they ask if they want you to pick one that's worse. Otherwise, just back it up correctly and you'll be fine. All right, use the confidence interval to determine or decide between the two hypotheses. What is an advantage of using a confidence interval for this purpose, and why don't we always use confidence intervals? Kind of on this one, if we were to make this one, because we rejected the null hypothesis, that means that the interval will not contain the value. So that also, some I'd like to ask, that makes it statistically significant. If the p-value is less than alpha, or if the value is not in the confidence interval, that's statistically significant. Also, when they talk about these problems, a 90% confidence interval is tied together with the two-sided test with an alpha value of 5%. So I guess you can think of it a two-sided, then you take the 5% and double it, and that's what's missing from 100 from the 90, but that you'll get the same result. So in the confidence interval, the value will not be in the interval, outside of the interval, if the p-value is less than alpha. The p-value is greater than alpha and you fail to reject, then it will be inside of the confidence interval. But again, you can't do an 80% confidence interval with 5% alpha. It has to match up, and it's got to be a two-sided test. All right, so on this one, they say, okay, well, we did a 95% confidence interval and we got this value. And I'm going to read the whole problem, okay? And because all values of the interval are below the 30.1%. We have reason to do a more thorough investigation. Just like in the previous problem when it was the test, we rejected the null hypothesis. All right, finishing out here. You can just put the you can just use the calculator for the do step, and they will not give you partial credit, but I'm telling you that doesn't seem to be a huge issue. As long as you do the inference method correct in the plan step, you can just write the answer for the do step because you're identifying it correctly. But again, if you have to identify it correctly in the plan step and then get the right answer, and no partial credit. All right, power of a test. Power is the probability of successfully rejecting the null hypothesis when in fact you should. All right, and so there you go. And the way I remember that is that the statistician has the power. So Oreos make a statement. I have evidence statistically that says that their stuff is wrong, and I would reject their null hypothesis. I have the power. They're writing me a check to shut up, or I'm going to go to the papers. I have the choice. I have the power because I can successfully reject the null hypothesis. That's what power is. All right. Now that we don't get into it too much, and there's a lot of confusion on what it is exactly, but the one thing I can tell you need to know, so again, I'll try to explain this, but also what do I need to know on the test, because that's all I really care about, and I get that, okay? Power, the way we'll solve it is 1 minus beta. Beta, remember, is the probability of a type 2 error. And say, well, how would I find beta then? Well, they would say beta is 23%, what's the power? Or they might say power is 23% and what's beta? And you do 1 minus whatever they give you. If you remember that, you probably will get the multiple choice question on the AP exam. It's not always that, but it's pretty much always that. It's one of the last questions. There's a ton of reading. And if you just see at the end, it says capital B equals 23%, and they'll say, what's the power? You don't have to read their story. You're listening to me blabber on now, but you won't have to read that story while you're taking your AP exam. And I have a problem to show that on the next page. All right, and then we got a bunch of other stuff, and I'm not even gonna talk about the problems. Here's what you need to know, and look at how I've written it out. This is stuff, if I'm taking the AP exam, if I was taking it, and it said, hey, what happens if I do sample size with power, any of this stuff, I just turn off my brain and I write this one down right here, okay? Smaller sample sizes is going to increase variability, and it's going to decrease the probability or the chances that I can successfully reject, right? Because maybe there'll be an error, okay? But if I increase my sample size, power goes up, because if I get the results, it's probably right because I had a large sample size, okay? Again, power, good. Large sample size is good. And if you don't know large sample sizes are good by this point, then you've got some catching up to do. All right, so that's what goes there. That one's pretty easy. This is the one they're more likely to ask you about, okay? Our significance level, alpha, goes up as power goes up, okay? Beta has an inverse relationship with both of them. As they go up, the other one goes down and vice versa. So I see a question on multiple choice. It's number 36. I'm exhausted. I don't want to do it anymore. Blah, 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 power. I close my brain off and I write this line down right here. And whether you write this one or this one, it doesn't matter. And then I read the question and I just go alpha up, power up, that's it. Or it's gonna be this one. Again, this is a memorization thing. It's not very teacherly of me to say this, but just memorize this and you'll be fine. All right, part C. What this is with the only, and again, we can do numbers and stuff, and you can read that. but here's the basically what's going on is power will increase if the gap between the true probability, the true proportion, or the true mean is far away from what we're trying to test. So the potato problem, they're saying, all right, we have to have at least 50% good potatoes. What's the? I'm sorry, they can only have. Well, maybe I should read this. So they're saying if there's a 50, they can only take the potatoes if it's 8% bad potatoes. So then they're saying, well, what happens if it will be easier? What happens to the power, okay, if it's truly 10% or truly 50%? Okay, now you would think, well, this would be better, right? Because that's just not as bad of a buy. If it has to be 8 and it's 10, that's pretty close. It has to be 8 and it's 50, that's a problem. It's just what we're saying here, it's gonna be easier to detect the bad batch. Our power is gonna increase. We're more likely to successfully reject the null hypothesis when the gap is big between the true proportion and what we need it to be for a successful collection. So hopefully that explains that pretty good. Over the years, that's the only way I've ever been able to explain it to make students nod and look like they understand what I'm talking about. Okay, and then also blocking. Blocking increases power. Or remember, stratifying is also pretty much the same thing as blocking. Blocking is the name of the experience. Stratifying is the name of the sampler. All right, so here we go. We're almost done. Got a whole page, but here we go. So it says, again, we got all this great stuff, and it says the power of the test is 76.76. Okay, interpret this value. So if the true population is 11%, we will reject successfully 76% of the time. And then I have a different way to write it. So basically, one way that came in my brain and one way that was the textbook, and I don't even remember which one's which anymore. Okay, then the next one says, what's the probability of a type 2 error? This is what I was talking about before. The power is 76%. What's the probability of type 2 error? 24%. 100% minus that 76. They might give you beta. They might give you power. Ask for the other one. It's going to be one of the last 7-8 questions on your test if you take the multiple choice. Everybody in the country does bad on it. I guarantee you we do good on it because it's on every release test I've ever seen, and I over-explain it just like I have already twice in one video. And then, again, if you'll just notice this last part, how can we increase the power of the test? This is good. This one increases power. This increases power. We could have said lower beta, too. I didn't write that down here. Well, we could have put lower beta or blocking or stratifying. That's how you increase power. You do these things. You can say, well, why don't you always just increase sample size? Well, it costs more money to increase the sample size, or it makes more work. And then an interpretation. Again, I don't need to read this. It just is what it is. You learn how to write it. This isn't one that gets tested a lot, so we don't talk about it. And then that very last question, full disclosure. I have no idea how we did that problem. It doesn't seem to be causing us trouble, so I'm just going to not know and to continue to not know, but there's the answers. If you want to show off, you can let us know how to work that one. I hope they find that helpful.